this is the extension to lesson 5.3. You should be on page 309. This extension is entitled Relating Arithmetic Sequences to Linear Functions. We definitely have some vocabulary that we need to address in this extension. The first term is sequence. A sequence is an ordered list of numbers. I can point to an example of a sequence right here. Like here would be a sequence of numbers, -4, 1, 6, 11, 16, and so on. That's a sequence. It's a list, an ordered list of numbers. Now, the next vocabulary word is the word terms. The numbers in the sequence are called terms. So if I was to ask you on a test, what are the terms of the sequence, you could write down the terms are -4 and 1 and 6 and 11 and 16 and so on. Each of those are called a term. Now, when you have an arithmetic sequence, that's the next vocabulary word, arithmetic sequence, the difference between the consecutive terms is constant. Now, we got to be careful with this definition. The difference, let's start there. The word difference means subtraction. So let's just remind ourselves of that. So what they're saying here is if we have an arithmetic sequence, if we subtract the terms, we ought to get a constant amount, which I'll show you in a minute. The constant amount is called the common difference. Let me get that out of the way. The constant amount is called the common difference. An arithmetic sequence would have the form, now when you see a sub 1, that's an algebraic way of saying we have the first term of the sequence, followed by the next term would be the first term plus the common difference, followed by the first term plus twice the common difference, and so on. This might look really complicated, but it's saying a very simple idea. I think it's going to be easier to show you an example. So let's do an example. Let's identify if the following examples are arithmetic sequences, and I can talk about what I just started here more. Okay, so is this an arithmetic sequence? Well, let's check. Let's check to see if the differences are constant. Well, let's check on the first difference. 1 minus -4, let's try that. Do you see where I'm getting 1 and -4 from? It's the first two terms. 1 minus -4 equals 5. Okay, let's take the next two terms and subtract those. 6 minus 1, it equals 5. Let's take the next two terms, 11 and 6. 11 minus 6 equals 5. Are you seeing, and let me highlight it, are you seeing that I'm always getting a common difference of 5? That means that this is an arithmetic sequence. So I'm just going to put, tell whether it's arithmetic. Yes, it is arithmetic. Now, remember I said this looks kind of complicated. Here's all it's saying. Take the first term, which is -4, write that down. This is saying if I take the first term -4 and add the common difference, which was 5, I'll get the second term. Let's do that. -4 plus 5 is 1. That's what that is. This is saying if I take the first term, which was -4, and add double 5, which is 10, -4 plus 5 is 6. This is just an algebraic way of showing that the arithmetic what the arithmetic sequence, I guess, would work out to. Okay? I'm not going to quiz you on this or test you on it. I just wanted you to explain to you what that means. Okay? Let's check to see if sample problem B, if this is a arithmetic sequence. Well, let's try. 5 minus 3 would equal 2. So the first difference is 2. Let's try the next one. 9 minus 5 is 4. Well, nope. This is not an arithmetic sequence because I'm not getting the same common difference. Okay? All right, next, let's talk about graphing a sequence. When you graph a sequence, here's the important thing. Let the term position number be the x value, and let the corresponding y value be the term itself. So, in the problem that we just did prior, in example A, which I'll write here, they gave us this sequence. You'll see it above. The -4 is the first term, the 1 is the second, the 6 is the third, the 11 is the fourth term, and 16 is the fifth term. Do you see how they took that and just wrote a table? After you write the table, you can plot the points. So over 1, down 4. Do you notice they have a scale of 5 here? That's why this is down 4, because here's 5. Over 2, up 1. Over 3, up 6. Over 4, up 11. Over 5, up 16. That's all you need to do to graph this. Make sure you number each term in the sequence, and the actual term is the y value. So again, here are the x values, here are the y values. You just have to graph it. Let's talk about functions. Notice the points you plotted in the last example lie on a line. Here's one thing we have to know. Arithmetic sequences are linear functions. That's why we're covering it in this chapter, because we're working on graphing linear and writing linear equations. A linear function belongs in this chapter. It's a straight line graph. You can think of the common difference, which they're labeling D, as the slope, and 1 and then the first term of the sequence, which if you're like, where is that coming from? Okay, if you're like, what the heck is that? What they're saying is the common difference is the slope, and if I go back a slide, they're saying this would be the first term. This would be 1, and this point would represent the first term of the sequence. That's why they call it a sub 1. So if I take the common difference in that point, I could write an equation. So let's write the equation, okay? And you can see it here. Here's the y value plugged in. Here's the x value plugged in. Here's the slope plugged in. And you can see they're rewriting an equation here in basically point-slope form, which is why this is an extension of lesson 5.3. This is an extension of point-slope form. Okay? So this little point-slope equation could be rewritten into this form, and this is the form that is the rule for an arithmetic sequence. This is a rule. Get this in your notes. We can find the nth term of a sequence if we know the first term and we know the common difference by this little formula. Now again, that looks really complicated. It's actually a simple formula. I'm going to show you it right now. Okay? Let's do an example. I want to find the 100th term in the sequence. Now there's two ways you can do that. You can either do it going one at a time, -4, 1, 6, 11, 20, 16, 21, 26, 31, 36. We could keep on going to the 100th term, but think how long that's going to take. No one in this room or no one watching this video is going to want to have to actually calculate every one of these numbers of the 100th term. So that's where this little formula comes in, and it's really simple to use. Here's how you use it. I want the 100th term, so you write a sub 100. Okay, now, what this says, the first term of the sequence, write the first term down, it's -4. Now, we want 100 terms. You already wrote the first term down. There's 99 more terms, so that's why it says n minus 1. I have 100 terms. I already wrote the first one down. That's where the -1 comes from. I have 99 more terms, and the common difference is 5. If you figure that out, you will get the 100th term. So let's put that in our calculator. So you can see here I put negative 4 plus 99 times 5 in my calculator, and I figured out that the 100th term of the sequence should be 491. So let's go back and write that in. So the 100th term should be 491. That's how I can find the 100th term. Let's just make sure that this little formula actually works. Can you see that the 4th term of our sequence should equal 11? Well, let's see if this formula would actually give me the right answer. So I want the 4th term. The first term is negative 4, plus I have 3 more terms to go. 4 minus 1 is 3, and my common difference is 5. So if I work this out, negative 4 plus 3 times 5 is 15, that does give me 11. Can you see how this formula actually gives me the whatever term you want? If you want the 1,000th term or 500th term, it will give you whatever term you want by using that. I'm going to pause the video here. If you have questions, make sure you ask her in class.